Video got cut off. So spiral matrix 3 we were discussing over here. The only observation that we needed to do was after every two sets of directions the step size increases by 1. So in each layer you have to traverse only one element first, then you have to change the direction. In the second time you'll have to traverse one element only, but in the third and fourth directions you'll have to traverse two elements, and then fourth and then in the fifth and sixth directions you'll have to traverse three elements each. So this increase of the number of elements in each layer happens every two times, like after every two layer iterations. We'll define some step over here, right? In that step we will be having that step from something to something, like it can go till infinity. The only stopping factor is that if our traversal size has reached rows into columns, if it has reached that, we know that already we have reached the we have already traversed all the array elements in each layer, right? In each of the layers what we will be doing is we will just go for two directions in each step. For each step we have two directions layers. For each layer I will go for step number of cells. After going for step number of cells, if something is happening or not, I will change the directions and I will go to the next cell directly. So, and then I will change the direction after I have traversed that layer. Basically it is the same. And spiral matrix 4 also, there was some other way also to do it, in the sense while we are traversing we have to make sure that we don't do the segmentation fault. Segmentation fault when it appears when, suppose we are on the last element of that particular column and then we go out of bound and directly we are assigning I plus equal to and j plus equal to without checking. So next time when it goes into the for loop it will give a segmentation fault. So to do that only, whether we can go out till here or not, whether our I and j is fit to go here or not, first we will find out what is our new I and new j, and then if that new I and new j is valid, then we will just update our I and j. But if those two are not valid, right, then we will change the direction and then we will update it after changing the direction. So we will know that it is a valid possibility. We will do that. This is the only thing, like only gotcha that I had in this particular method, but it can be directly solved from the template we discussed in the earlier video. Now over here just a quick reminder. So suppose I start from the start index, right? I am at the start index. I will just do the process over here because this j will be equal to 0 and then j is less than 1. So only one time this loop will run. In the first time it will check if the thing is valid. If it is valid, yes, it is valid over here, the start is valid. And now if it is valid, we will say that we will do this process of RC. I did the process of RC, then I am adding the direction also. So right now my I and j have moved till here, row and column. My row and column are already here, but what you notice is it has come out of the loop already. So my first layer iteration is already done, layer 1 iteration is already done. Now when it has moved over here, right, I have changed the direction directly. I have changed the direction to go downwards. Now it will come here, it will process this, and then the next part will be this, and then again after doing this, right, it will directly change the direction. So our layer 1, layer 2 traversal is over here only, and it will come over here. Now our RNC is this. Now when it is over here, now my step size also increases, right, because two layers have completed, step size increased. Now for two parts it will first it will do this, it will move here, and then it will do this and it will move over here before changing the direction. So the next layer will be completed over here, layer 3. Now it has come already over here, it will go here, right, and then again it will go over here. Layer 4 ends over here, and now again step plus plus happens. Similarly this is the case wherever we are going, right, we are doing this kind of a feature. Now this process part, this takes care to add into the traversed array only when we are at a valid cell, we will go into invalid spaces also, but we won't be doing any processes over there. So this part will always hold true, right?